So not sure what happened there. I think the iPad just kind of glitched and closed out. But to finish that last statement, 0.3 times 0.2 does not give you 0.5. It should give you 0.6. So we know that they're not independent. We know that there's something else going on there. It would be dependent. Okay, so for examples, this table below shows the results of a survey of 11th and 12th grade that either have a job or don't have a job in the past summer. Okay, so 11th grade that do have a job 18, that don't have a job is 22. So when we add that up, that'll give us 40. Same thing for 12th grade. And then the ones who don't have a job, we add those up, that will be 32. The ones who did have a job, add those up, that will be 48. Either way, you have 80 total. Okay, so that total is 80 people who we have asked. So these tables are really, really useful when it comes to intersections and unions. So find the probability of J, they had a job, and T, they're in 12th grade. So the probability that they did have a job and they're in 12th grade would be 30 out of the total number of students, 80, right? And that would be 37.5%. So then we can find the probability that they are either did not have a job or in 12th grade, right? So here, what we're going to do is we're going to find the people who did not have a job, the total number of people, right, that did not have a job, that will be 32. And then the total number of people in 12th grade, which will be 40. And then we need to subtract their intersection, right? So we have the total number of people who don't have a job, 32, or didn't have a job. The total number of 12th graders, 40. Well, there's 10 of them that we just counted twice, right? Within that 32 and 40, there's 10 of them that we counted twice. So if we subtract 10, that will be only counting them once. That will be 62 out of 80, which will be 77.5%. Lastly, we'll do the same thing with not having a job and 11th graders. So the ones that didn't have a job, it's 32. Or 11th grade, 40. And then we need to subtract the 11th graders who did not have a job, 22. So when we subtract those, that will give you exactly 50 over 80, and that should give you 62.5%. Okay? Another one just like this right down here. I'll work this one out with you, and then we'll be done. So we have an optional workshop for players' basketball skills, and the people who improved and did not improve, and the people who attended and did not attend. Definitely attend anything if you have a chance to better yourself. Come on now. So the total here will be 50, and the total there will be 50. The people who improved and then did not improve. The total that did not attend would be 38, and the total that did attend would be 62. So 100 basketball players total. So find the probability that a player chosen at random attended the workshop and showed improvement. So for this, we're just looking for the ones who attended the workshop and improved. That will be 44, right? So this is really simple. 44 out of 100, 44%, okay? Find the probability that a player chosen at random did not attend the workshop and showed improvement. So they did not attend and showed improvement. That's only 6 people. And that would be 6%. And you best believe those people were not just sitting there on their tails playing video games all summer or all quarantine. They were actually working on their skills. Athletes, band players, anybody who has a skill that they should be working at, this is a great time to do so. Find the probability that a player chosen at random attended the workshop or showed improvement. So the past two were and, now we're doing or. So we're going to add these two. The player attended the workshop. Let me clear these up. So the probability that a player attended the workshop would be 62, and then or showed improvement would be 50. Well, obviously, if we add those together, 62 and 50 is going to be over 100, right? So we need to subtract the intersection of those two, which would be 44, because we just counted those 44 people twice. So that would be 68 out of 100, and that would be 68%. If you guys got any questions on this practice, feel free to shoot me an email, but a lot of it is really, really similar to what we just did. So look back up here in these notes, listen to this video one more time. Hopefully these will